Thank you, Dave. Good afternoon to everyone. It's always nice to get to the AGU meetings. This is a symposium that sort of grew out of discussions among folks involved in the Long-Term Agro-Ecosystem Research Network, or the LTAR Network. We're kind of a new network on the block, and one that's focused more or less specifically on agro-ecosystems and agricultural landscapes. So I'd like to start off. How do I advance the slides? Yeah? Okay. I'd like to start off by thanking Dave Huggins, who is the primary convener, co-conveners Phil Robertson from Michigan State, Brian Wee from NEON, Mike Kosh from USDA ARS, and note the chairs Dave Huggins and Brian Wee for this session. So in the agricultural world, there's so many people here who are knowledgeable on various issues related to climate change, and I know this will resonate, but in the agricultural world, we are very, very aware of huge challenges facing our community this century. We are expecting a global population of approximately 9.7 billion people now by 2050. When I first started talking about LTAR, it was 9 billion. Now it's 9.7. Estimates have gone up. And those 9.7 billion people are going to want more products than many of them currently have as developing nations become more developed and want higher quality and more foodstuffs and other agricultural products. We pretty much have to survive this and to feed all of these people, we pretty much have to do it without any further depletion or degradation to our natural resource base and the environment. And we have to do this against the background of a changing, or at least a highly variable climate that at least is predicted to alter the very patterns of precipitation and temperature upon which our agricultural systems depend for productivity. These are huge challenges that threaten global food security, the availability of fresh water, and other factors. Just very, very significant challenges. The FAO estimated in a 2011 report that 25% of Earth's lands are already degraded, so we really can't afford to go much further down that road. We've already trashed about a quarter of the planet. But more importantly, some people say, well, okay, we have to increase production to meet these growing needs. We'll just bring more lands into production. But in fact, FAO estimated that 3/4 of the 70% increase in global food production needed is going to have to come from intensifying production on lands that are already under cultivation, so sustainable intensification, if you will. Now, these are huge challenges. Over the last 10 to 15 years, there have been many calls for the creation of a long-term agro-ecosystem research network to help us address these impending challenges. Some people in this room have been very active and significant in bringing this to the scientific community, and in 2011, my colleague Dr. Steve Schaefer and myself summarized the calls for these for an LTAR network. And basically, this network would provide infrastructure to enable research on agricultural processes from field to landscape scales. It would support long-term investigations into the key components of sustainable intensification of agricultural production. Such a network would provide historical data records. It would be built on infrastructure that has historical data records that would give us a baseline against which to evaluate future changes. But most importantly, this network would collect a series of common data sets using shared research protocols over the next 30 to 50 years, and I have consistently argued that these common data sets collected over the next 30 to 50 years would probably be the most important data sets that would be collected by such a network. So in this talk today, I'd like to briefly describe how in the Agricultural Research Service and working with our partners, we took existing infrastructure and organized it into an LTAR network. We're about 2.5 years old at this point. Sort of tell you where we are on the status of this network, and then outline our future plans. And we really convened this looking for perspectives, lessons learned, and to get a lot of insights from the speakers who will follow in subsequent talks today. So the first 10 sites of the LTAR network were announced in 2012, in February of 2012. So like I say, we're about 2.5 years old. And the sites were chosen based on 7 criteria. We were looking for productive teams. They had to have an established track record. We were looking for sites that had infrastructure capacity. They had to have some sort of a large-scale instrumented watershed or long-term research facility large enough to capture landscape-scale processes. We were looking for research groups that already had rich data sets, rich historical data sets, and we were looking for groups that had already gone down the road to make those data available to the scientific community at large. We were looking to build a network that gave good geographic coverage of key agro-ecosystems and agricultural landscapes in the U.S. We wanted people who were already had well-established existing partnerships, because we recognized that this was something that our agency and even USDA at large could not do alone. And we were looking for an institutional commitment from our own organization to keep these sites going for the next 30 to 50 years. The first call was an internal call for ARS locations alone. People had been calling for this network. We knew we had the infrastructure to get it started. We wanted to sort of set something up, get it started, and then bring in partners from outside of our own agency and potentially from outside of USDA. Earlier this year, we added 8 new sites to the network, filling in critical gaps that sort of appeared after the first call. Florida, for example, using the Archbold Biological Station and University of Florida partnership. The Great Basin, built partly on our Reynolds Creek experimental watershed. The Great Lakes, bringing in the Kellogg Biological Station, which is an LTER site. A High Plains Aquifer North Platte River site, which builds a strong partnership between the University of Nebraska at Lincoln and ARS locations in Nebraska. A site in the lower Chesapeake Bay. We had one in the upper, but we wanted something down in the main stem of the bay. Lower Mississippi River Basin, the Ohio River Basin or Eastern Corn Belt site, and the Texas Gulf Coast. Through this call and selecting these 8 additional sites, we extended the LTAR network to partner sites outside of both ARS and USDA. And we expanded our coverage to include new networks. We were already partnering with LTER, NEON, and other networks, Ameriflux, but we brought in the Critical Zone Observatory in partnership through the Reynolds Creek Experimental Watershed, a newly named Critical Zone Observatory, and the National Network of Biological Field Stations. So at the outset, we established a few key operating principles, and we've always viewed LTAR as something that would sort of walk a fine line between a NEON-like observatory and an LTER-like ecological, not ecological, but LTER-like watershed or ecosystem research network. And the first operating principle was that we would develop shared research questions across the sites, and that would be coordinated across sites. That we would provide the capacity to address these questions through shared research protocols. So this is not going to be a situation of everybody doing their own thing and getting together once a year to shake hands and have a beer and talk about their research. We would collect compatible data sets across these sites and provide the capacity and infrastructure for cross-site data analysis. And maybe most importantly, we would facilitate and foster shared engagement in thinking and acting like a true network, something that we had Dr. Dave Goodrich will talk about our ARS benchmark watershed research network, which functioned a little less cohesively, not very effectively, but sort of more as a collection of individual sites. We wanted something that was moving together forward as a number of sites all working in concert. So we now have 18 sites. The historical data records extend from and actually this slide is slightly out of date, so maybe 13 to 14 years to a little over 100 years. A couple of our sites have 100-year data records for some data streams. The footprints range from about a half a square kilometer to more than 6,200 square kilometers, and we've encouraged that these sites would think regionally rather than locally to develop partnerships within the regions that they represent to bring in numerous sites that would all be working together on the network. We have sites in 11 of the 17 NEON domains in the lower 48 states, 12 of the 18 major drainage basins or HUC2 watersheds, and 8 of the 9 farm resource regions as identified by the Economic Research Service. And this is a map which shows you the network as it stands right now. Hey, look at that. So we have 2 sites now in the Chesapeake Bay, one that is focused in the Susquehanna River Basin and one in the lower stem. We have a Gulf Atlantic coastal plain location, Archbold Biological Station, which covers subtropical or humid pasture lands in southern Florida. We have very good granularity in the Mississippi River Basin with an upper, central, and lower Mississippi River Basin site, an Ohio River Basin site, and a southern plain site that covers the Red River Basin, as well as a Texas Gulf Coast site. We've got the Great Lakes covered primarily with the Kellogg Biological Station with some support from this Eastern Corn Belt group. We've got a nice latitudinal gradient through the plains with the Northern Plains site in North Dakota, Central Plains and High Plain aquifer sites in the Central Rangelands, and a Southern Plains site at El Reno, Oklahoma. 2 arid rangeland sites, the Jornada Experimental Range and the Walnut Gulch Experimental Watershed, which represent both an aridity gradient as well as one site focused more on rangeland desertification and one focused more on hydrologic processes. And then our Great Basin site and the Cook Agronomy Farm, which covers the wheat-producing Palouse region of the Pacific Northwest. We've written a shared research strategy, which is posted on the web, and this is the LTAR website where you can find more information about the network. And this strategy it serves as a roadmap for research that will be done in the LTAR network, focusing on agro-ecosystem productivity, climate variability and change, conservation and environmental quality, and socioeconomic viability and opportunities, producing 4 key products: new knowledge of processes and systems, new technologies and management practices, improved agroecological models, and comprehensive and accessible data. I'm going to pass on that one. We have some future plans. One of the best thing that's happened to LTAR recently was a $10 million budget increase, which is $1 million per site for the initial 10 sites, and that is an annual investment by the federal government, not a one-time deal. We've sort of refined our central question to be how do we sustain or enhance productivity, profitability, and ecosystem services in agroecosystems and agricultural landscapes. We're in the process of designing an LTAR observatory component that would be complementary but not necessarily duplicative of the NEON network. We're establishing a cross-site experiment in sustainability across all 18 sites. And we're working on several products over the next couple of years, revising that strategy to bring the new 8 sites into it, a bioscience article about LTAR, a paper on rainfall intensity and soil erosion, mining the historical data sets that LTAR represents, and a review paper on interannual productivity, as well as implementing the GraceNet network across LTAR. We have it in some sites currently, but not all. So, agriculture faces huge challenges over the coming century. Addressing these challenges is going to require transformative changes to the way that we do agriculture. Establishing an LTAR network for U.S. agroecosystems is an important component of understanding how to make these changes. And within USDA, we have leveraged existing infrastructure and built on that and developed partnerships to fill in key gaps in this network to provide an LTAR network for agriculture. Thank you very much.